Let A and B belongs to power set of a fuzzy set X, and alpha beta belongs to closed interval 0 1, and then the following property holds. The first one is a strong alpha cut of A is a subset of alpha cut of A. Second property is, if alpha is less than equal to beta, this implies beta cut of A is a subset of alpha cut of A. And third one, alpha A intersection alpha B is equal to alpha of A intersection B. This is the first part. And second is alpha of A union alpha of B is equal to alpha of A union B. And the fourth property, strong alpha cut of A intersection strong alpha cut of a B is the same as strong alpha cut of A intersection B. And second of this B part, this is A, strong alpha cut of A union strong alpha cut of a B is same as strong alpha cut of A union B. And the fifth one is alpha cut of A bar is the same as 1 minus alpha strong alpha cut of A bar. Now the proof of this, the first one, by the definition of a strong alpha cut, we know that strong alpha cut of A is the set of all X belonging to X such that whose membership value is always greater than alpha. And the definition of alpha cut is the set of all X belonging to the capital X inverse of discourse if membership function of Ax is greater than equal to alpha. Now by the definition we know that A is a subset of B. तो इसका हम प्रूफ कैसे करते हैं कि इस सेट का हम कोई एलिमेंट ले लेते हैं, लेट x belongs to this one, then we want to show that x is also belongs to this one. So taking let x belongs to strong alpha cut of A, then by definition this implies A of x is always greater than equal to alpha, and we know that this alpha can be written as greater than or equal to alpha. Now इसको हम neglect कर दें, so we can write Ax is always greater than equal to alpha. And so by the definition of this, x belongs to alpha cut of A. तो हमने यहाँ से ये लिया था और हम भी प्रूव कर चुके हैं. It means this set is a subset of this one. So this implies a strong alpha cut of A is a subset of a alpha of A. Similarly, we can find the second, we can prove the second property. If alpha is less than equal to beta, then this implies beta cut of A is a subset of a alpha cut of A. Again, from this, it means this is a subset of this. So taking any element of this, and we want to show that this is also the element of this. So let x belongs to beta cut of a. So by definition a of x is greater than equal to beta, and this is also given beta is greater than equal to alpha. So by this property ax is greater than equal to beta and beta is greater than to alpha by this one. It means again इसको हम थोड़ी देर कैंसिल कर दें. So we can write down ax is greater than equal to alpha, and so again by the definition it means this x belongs to alpha cut of a. So x belongs to this one and x is also belongs to this. It means this is a subset of, so beta cut of a is a subset of alpha cut of a. Now comes to the third property. Alpha of a intersection b is equal to alpha of a intersection alpha of b. Now we want to show that these two sets are equal. By the definition we know that a is equal to b if and only if a is a subset of a b and b is a subset of a. तो हम ये वाली प्रॉपर्टी इसमें अप्लाई करेंगे. तो लेट x belongs to this. First of all we want that this is a subset of this one. So let x belongs to alpha of a intersection b. So by definition this is a intersection b of x is always greater than equal to alpha. So the definition of a intersection of a fuzzy two set, it means the minimum of ax comma minimum of bx is always greater than equal to alpha. This implies ax is greater than to alpha and bx is also greater than equal to alpha. Again by the definition of a alpha cut, it means this implies x belongs to alpha of a and x belongs to alpha of b. Again by the definition of a intersection, so this implies x belongs to alpha a intersection alpha b. So if this implies from this alpha of a intersection b is a subset of alpha a intersection alpha b. Let this is the first equation. Now we want to show that this is a subset of this one. So let alpha a intersection alpha b, let x belongs to this one. So by the definition of an intersection we know that x belongs to alpha a and x belongs to alpha b. Again so this implies x belongs to this alpha of a, it means ax is greater than equal to alpha and b of x is also greater than to alpha. By the definition of a minimum property, so this implies clearly the minimum of ax comma bx is also greater than equal to alpha, and so this is nothing but the intersection of a fuzzy two set a and b. So this implies a intersection b of x is greater than equal to alpha. So by the definition of alpha cut, so x belongs to alpha cut of A intersection B. So this is the second. Then again the first from this and this, we can say write down alpha of A intersection alpha of B is a subset of alpha of A intersection B, and hence the theorem. Now the second one is a union. So B part of it is alpha cut of A union B is a same alpha of A union alpha of B. Again we want to show that this is a subset of this one, and then this is a subset of this one. Well, first we want to show that this is a subset of this. For this, let X belongs to alpha of A union B. Then by the definition of a union of a two fuzzy set, this implies A union B of X is greater than equal to alpha. It means by definition again the maximum of AX comma B of X is greater than equal to alpha. So maximum of this implies either this is greater than equal to alpha or this is greater than equal to alpha. So this AX is greater than equal to alpha due to this maximum means, or BX is greater than equal to 1. So this implies X belongs to alpha of A and X belongs to alpha of B. Sorry, not this, or. So this implies X belongs to alpha A union alpha B. Therefore, alpha of A union B is a subset of alpha A union alpha B. Now this is the first equation. Now we want to show that this is a subset of this one. For this, let X belongs to alpha A union alpha B. Again, by the definition of a union, X belongs to X belongs to this one, so this implies X belongs to alpha A or X belongs to alpha of B. Again, this implies the membership function of a AX is always greater than equal to X, or membership function of a BX is always greater than equal to alpha. So again, by definition, AX, we can write down AX maximum of AX comma BX is always greater than equal to alpha. Again, by this definition, this is A union B of X